Math 8. Today we will compare properties of functions. You can represent two different functions in many different ways. We can use tables, graphs, equations, or words. To compare two functions, we can use different forms of these table, graphs, equations, or words to see what the rate of change is between the two functions to compare them. So remember, the rate of change is the speed at which a variable changes over a specific period of time. So let's look at an example so we can find the rate of change in one function, so then we can use it to compare two functions. So let's look at our example. Worried about going over a storage limit, Ernesto monitored the number of undeleted voicemail messages stored on his phone each day. So we have a table for this function. So remember, we can do a table, a graph, words, or an equation to represent a function. So in this case, it's a table. So when we look at this table, we notice that we have our days and our voicemail messages. So we can make those into variables using our table. So we're going to make our days our X value and our voice messages our Y value. Just notice how this looks just like an XY table that we have done before. So now we see Tuesday, Wednesday, Thursday, Friday, Saturday as our X values, and our voicemail messages are 1, 12, 1, 17, and 20. Since our X values are not in numbers, we can just assign them a number. So since Tuesday's our first day, we just start with 1, and then Tuesday, the day after Tuesday, is Wednesday. So that's just a change of 1. So Wednesday can be day 2, Thursday is day 3, Friday is day 4, and Saturday is day 5. So now, in order to compare the rate of change, we take the change in our Y value divided by the change in our X value. So, according to the table, it wants to know between Thursday and Friday. So we're just looking at this part of the table. So when we look at this part of the table, our change in Y, so we're going from 17 minus 1, and our change in X is 4 minus 3. Now notice that my 17 and 4 line up because they are on the same part of the table. If we were graphing these ordered pairs, it would be 4, 17. So make sure when you do your division problem that you have them lined up. So 17 minus 1 is 16, 4 minus 3 is 1. So our rate of change between Thursday and Friday is 16, or 16 over 1. Let's try an example. A zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of the zebra. Compare their speeds. Okay, so we know some information from this problem. We know that lions can run 53 feet per second, and we're not sure yet what the zebra can run. So, to compare their speeds, we compare their rates of change. So we know one rate of change. Now we have to use the graph to find the second rate of change. So the lion can travel at the rate of 53 per second. Now let's find the zebra. So to find the rate of change for a zebra, we choose 2 points on the line and then find the rate of change between them. So remember, it's the change in Y over the change in X. So if we're going to use these first 2 points, then we can circle them for our graph to use that data. So remember, we take the Y values first. So 118 minus 59. Remember, ordered pairs are always written XY. So our Y is our 118 and our 59. And our X will be 2 minus 1. So 118 minus 59 is 59 over 2 minus 1, which is 1. So the zebra can actually run at a 59 feet per second pace. So the zebra speed is greater than the lion's. Let's try another one. The flow rate of water in a water garden is 52 gallons per minute. The graph shows the flow rate of water in a koi pond. Compare the functions by comparing their rates of change. Okay, so we already know the water garden, and I'm going to label that WG. And we already know their rate of change because it's given to us in the problem. Gallons per minute. So now we have to find the rate of change where our koi pond. So first we find the change, and that's the triangle, change in y over change in x. So we're going to use the 2 points that are labeled on our graph, and we're going to write their ordered pairs out. So this would be 2, 120, and when we follow this up, we get 4, 240. So now that we have our 2 points, we find our change, so 240 minus 120, and then line it up. So with 240 is 4, minus 120 has 2. So notice this change on the bottom is not 1. So we're going to just keep simplifying. So 240 minus 120 is 120, and 4 minus 2 is 2. So 120 divided by 2 is 60 over 1. Or our rate of change for the koi pond is 60 gallons per minute. So 52 compared to 60, well, we know that our 60 is greater. So the koi pond has a greater flow rate of water than the water garden. Let's see if you can give it a try. Pause now and do this got it problem. Remember, compare the function in the problem to the graph and find out which one has a larger rate of change. Pause now. Welcome back. Now we're going to look at the y-intercept of functions and their rates of change. So remember, if we go back to the graph, when you think about it, you think where it hits that y-intercept. So remember, if it's hitting that y-intercept, so if it's right here on our graph, then x has to be 0. So that's something that you have to keep in mind. So let's read this. The function m equals 140h, where m is the miles traveled in h hours, represents the speed of the first Japanese high-speed train. The speed of the high-speed train operating today in China is shown in the table. Assume that the relationship between the two quantities is linear. That means that it has a constant rate of change. So from 1 to 2 hours and 2 to 3 hours, the rate of change will be the same. Okay, so now we're going to compare their y-intercepts. And since we're talking about two trains, we know that if the train has not moved from the station, there is no hours or no miles traveled. So in both cases, hours would be 0 and miles would be 0. So our y-intercept for both equations would be 0 in this real-world problem. So now that we've compared their y-intercepts, we're now going to look at their rates of change. And since the y-intercepts are both the same, we can't just compare that. So now when we're looking at this function, m equals 140h, we know right away that our rate of change is 140. So that's what's happening every hour, is we will travel 140 miles. So the rate of change for the Japan train is 140 miles per hour. Now we need to complete our table to see what our rate of change is for China. So this is Japan, and now we're going to look at China. So now we just look at our table, and remember we can look at this as x and y. So we're just going to take the change in these two parts of our table. So if we do 434, change in our y's, minus 217, then we're going to have 2 minus 1. So our change is going to be 217 over 1. So in this case, our rate for our China train is going to be 217 miles per hour. Therefore, the Chinese train is faster than the Japanese train. Now we're going to look at part B. So now it says, if you ride each train for 5 hours, how far will you go? So in the first train for pan, we put in our 5 for h and solve. So m equals 140 times 5. So then we get what our m will equal. So remember, anytime you're substituting in for a variable, we use parentheses. And parentheses mean multiplication. So 140 times 5 is 700 miles. Now let's look at Chinese. So in this case, we're not very far to add a couple hours to our table, so it may be just easier to continue our table. So we're going to do that this time. But if we had to do how many 10 hours was, it would be a lot more work to continue the table, and we can use an equation to help us with that. But since we know the rate of change is 217 every time, we just can add 217 to 651 to get how many miles we would travel for 4 hours. And then for adding again our 217 miles in the next hour, and we'll get 1,085. So in China, we would travel 1,085 miles, which is greater than 700 miles if we were on the Japanese train. Okay, let's look at another example. A bowling alley offers different birthday packages. Package A is represented by the function C equals 7p plus 5, where C is the total cost and p is the number of people. Package B is represented to the table. So now we need to look at the y-intercepts. And since this equation has a value after the rate of change, that means that is our y-intercept. Because remember, if we look at C equals 7p plus 5, and we put in 0 for p to solve for C, we're going to get C equals 7 times 0 plus 5. So in this case, our y-intercept would be 5. Now if we look at package B, it just is going by 1, 2, 3, 4 people. And it does not give any information that package B has a cost in addition to the number of people. So in this case, in this table, our y-intercept is 0 because there's no package cost, there's only a cost per person. So we've compared their y-intercepts. Now let's look at their rate of change to see which package is a better deal for 12 people. So in this case, our rate of change for package A is 7, and that's per person. And then our package B rate of change will be our 18 minus 9. So I'm looking at these two, and you can pick any two parts in the table as long as you're picking the corresponding number of people. So 18 is 2 people and 9 is 1. So we get our rate of change of 9 over 1. Now it's not so simple just to compare their rate of change in this one because their y-intercepts are different. That means there's a cost to package A in addition to the $7 per person. So now we have to put in our 12 people in both scenarios to see what we find. So with our equation, we have the C equals 7p plus 5. We substitute in 12 for p, and we find what our cost would be for 12 people. So you just do 7 times 12 and then add 5 to that, and you get 89. So now let's compare package B. So now package B, it just costs us $9 per person. So the cost is 9p. So if we put in 12 for our p, we will see that 9 times 12 is $108. So it would be best if we were going to have 12 people to choose package A. Pause now and see if you understand comparing functions with an equation and a graph. Remember to compare both their y-intercepts and rates of change and then solve for the problem. Pause now. Welcome back. Let's look at one more example. Lorena's mother needs to rent a truck to move some furniture. The cost to rent a truck from 2 different companies is shown in the table in the graph. So in this case, we have a table and a graph, no equation. Now it's asking which company should we use to rent a truck for 40 miles. So we can easily see from our graph and our table that 40 miles is not too off from what's displayed to us. Now we notice in the table that Ron's Rentals is going up by tens. So our rate of change is not 1. We're going up by 10 on the mile side and 25 on the cost side. So if we look at that rate of change, 50 minus 25 over 20 minus 10, we will see 50 minus 25 is 25 over 10. So then if we reduce that, and remember you can always reduce in your calculator as well, so we can see that it's 2 1/2 is our rate of change in this case. So what's happening is if I go from 30 to 40, I went up my 10. Now I need to go up my 25 on this side. So for 40 miles, I would have $100 in cost. Now, the graph has the arrow continuing on for crosstown movers, but it doesn't quite go to 40. So if we put our dot here, we could estimate that it will cost us $50. But let's actually use our rate of change and our y-intercept to make sure that that graph would continue all the way to the 50. So in this case, for crosstown movers, our rate of change will be our 45 minus 35 over 30 minus 10. So when we find that, we get 45 minus 35 is 10, and 30 minus 10 is 20, which that would reduce to a rate of change of 1/2. So this is our rate of change. Okay? Now we notice that our y-intercept is at 30. So if we wrote this out, we would have our y equals 1/2 x plus 30. So that is in our y equals mx plus b form. Then we have our equation. We can sub in 40 to find out if 50 is really going to be the cost for crosstown movers. So y equals 1/2 of 40, because that's our miles, plus 30. So does y equal 50? Well, half of 40 is 20, plus 30 is 50. So yes, if we continued the graph and our algebraic equation matches. So in this case it says, which company should we use? We should definitely use crosstown movers, because going our 40 miles, it's going to cost us half the price of Ron's Rentals. Thanks for listening and have a great day.